Good afternoon. It's a real pleasure to introduce today's lecturer, Virginia Sanfratello, architect, interior designer, and educator. And she is currently serving as the chair of the Department of Design at San Jose State University in, you know, West Coast. So she traveled all the way from West Coast yesterday. I had the pleasure of briefly meeting her last night, and I learned about the different structure of their school, and it's quite interesting that they have multiple different departments, multiple different programs under a School of Design. So she's also a partner at Real San Fratello and Emerging Objects and a co-founder of Forest. Her work has been widely recognized. She's a recipient of the National Design Award for Digital Design, Metropolis Magazine's Next Gen Design Competition, and International Interior Design Educator of the Year Award. Together with Rael Sanfratello, she was named an emerging voice by the Architectural League of New York, and their work received the BuzzFeed Design of the Year Award in 2021. Well, we also have in our own department previous recipients of both the National Design Award for Digital Design and the Emerging Voice Distinction, Felicia and also DK. So it feels particularly meaningful to welcome Virginia today as part of this broader community of innovative designers whose work continually expands the boundaries of design, but also material exploration. So her projects are part of the permanent collection of major institutions, including MoMA, the Cooper Hewitt, SF MoMA, and the Design Museum in London, among many others. She's also the co-author of Printing Architecture, Innovative Recipes for 3D Printing. I have a copy if anyone's interested, which explores experimental materiality through case studies of 3D printing with grape skins, salt, sawdust, and many other unexpected materials. So on a personal note, her work, especially also through emerging objects, has been a constant source of inspiration for me since my own graduate school years. They hack existing tools and materials, transforming everyday substances like salt, tea, coffee, etc., into architectural building materials and components has profoundly shaped also my thinking about material experimentation and teaching. I'm also especially excited to welcome her here in person today, as in our school and department, we have many like-minded faculty and students who explore materials and tools, whether digital or analog, in open-ended, experimental, creative ways. So I'm sure her talk, titled Drawn Out of the Lab and Into the Landscape, will resonate deeply and spark further inspiration into our community of makers, designers, creative explorers. So please join me in welcoming Virginia Sanfratello.
Thanks so much. Can you hear me in the back? Yeah, great. Well, happy afternoon. I'm so delighted to be here today to have the opportunity to share my journey into developing materials for 3D printing in my lab and more recently out of it. With you today, that sounds like based on the introduction. Thank you for that. And also just a little bit of a peek into your Instagram website. We have a lot in common, right? So let's get started. So the lab, emerging objects is not a traditional architecture interior design studio. Like material scientists working in a lab, or maybe like a tech startup in Silicon Valley, something in between the two. We have University of Berkeley, it's here, and even smaller than San Jose State University, where we've done a lot of this research into developing materials for 3D printing. Materials like Chardonnay, coffee, tea, etc. And I'll run through all of that today. One of the things that we like to think about as we're developing materials or as we're manufacturing is how we can use materials that are local to us in San Francisco Bay Area, and also materials that are in the waste stream. So Chardonnay, for example, is a material that is very local to us in Northern California. And we wondered if it would be possible to 3D print with Chardonnay grape seeds and skins, which you can see here, And we worked with a company that was taking this agricultural waste from the wine producing region all around us to grind up those seeds and dried skins into a flour that we could then 3D print with. So here you can see these 3D printed Chardonnay wine goblets that are quite literally made of Chardonnay, but of course you can do Chardonnay out of these goblets. We worked with individuals from Max's design to develop this 3D printed Chardonnay building block, which has a texture or an emboss on the surface that is reminiscent of a raisin. Still wants to become. And that block is radially arrayed and finished. I studied for the company to display their product at this kind of base. Yeah, it's on. Yeah. So maybe. Is that better? Okay, well, we'll find out. Coffee, this is another material that is local. It's ubiquitously local, right? It's everywhere. It's a waste product all around the world. But I drink a cup of coffee in the morning, and I remember one day sitting at my kitchen table and stirring up coffee grounds, and I thought, wait, why am I throwing this away? Why don't you 3D? And so I saved my coffee grounds over the course of a month, and I dehydrated them and ground them up in my coffee grinder and took them in my binder jet 3D printed to make this coffee cup out of my own coffee waste. And these are, well, that was a coffee pot. These are coffee cups, which out of my own recycled coffee grounds, but rather they're made out of the fruit that surrounds the seed of the coffee cherry. So the seed is the bean that goes on to be roasted and become that morning cup of coffee, but the cherry is an agricultural waste product and it's thrown away. And so there are just piles and piles of this waste material. So again, we worked with a company that was taking this fruit and dehydrating it and making a kind of caffeinated flour that you could bake with. And this material works really well in additive manufacturing. So we made cups to go with the pot. I also 3D printed sugar spoons in volumes corresponding to 1, 2, 3, 2, 3, tablespoon and beyond, so that you could stir that bit of sweetness down into your coffee to flavor it in the morning. Tea, similar to coffee, has a lot of waste, but we throw away the tea leaves after we finish brewing our cup of tea. There's also in the production of instant tea, lots of tea solids that are going to waste in factory floor. So we use those tea solids to quite literally 3D print teaspoons and teacups and a teapot, which you'll probably recognize as the Utah teapot, designed by Martin Newell at the University of Utah. This is one of the first open source models, which has been used to test lots of different rendering techniques. It's since the 1970s, and you've probably seen it in every Pixar movie, but we thought, why not bring it back to life into the physical world by 3D printing it out of steel. Curry, this was an interesting experiment. A lot of the materials we were printing before, like the coffee and tea, were brown. And I came to this idea to 3D print with curry because I was interested in having a new, vibrant color. But what I discovered is that the color wasn't quite as important as the aroma of the curry was. So this is the curry casserole that was 3D printed out of curry. And the entire time I was printing this in the lab, I could taste and smell the curry, and it was so wonderful and overwhelming at the same time. And as I talk about it now, I can still taste it in the back of my mouth. But because there was such wonderful aromatic sensation, which isn't something that we usually think about happening as an effect of 3D printing, I decided to leave the interior of this piece unfinished so that it would literally season the interior of the rooms in which it occupied. And you could potentially also maybe put rocks or noodles in here to season the food with the 3D printed stuff. Cochineal. Cochineal are little insects that grow or live in the southwestern part of the United States, in Central and South America. These insects become the original red dye, which was used to dye the red coats of the British Army. It's often used to dye our food. So we were invited by the Smithsonian to think about developing manufacturing. And we decided to use it as a dye in a stereolithography printer with their proprietary resins to print various shades of pink and red that you can see here. This is the cochineal added to the resin, a clear resin on top and a white resin on the bottom. Different color combinations. And I'll just say, you know, I put my own materials in their printer, which you can do too if you want. You'll go the warranty, but it worked out okay. Rubber. This is a material that is very, very hard to recycle. It is, of course, intended for but in the United States, you send about, I think, 280 million tires to either landfill or recycling. Not all of it is recycled. I think about 60% goes to landfill. So this poses a problem not only in our country, but around the world. This is the largest tire graveyard in the world. It's in Jordan. You can see it from outer space. To give you a sense of that, these are buildings. So there's a massive problem. How do we recycle and upcycle this material? So we worked with a company called Lehigh Technologies, which is actually here in Pennsylvania. And they take these rubber tires and they freeze them and reduce them to a rubber crumb, which you're all familiar with. It's that kind of swishy material that you see on playgrounds and rooftops, curbs. They grind it up even finer into this, they call it MRP, it's a micro fine powder that we were able to put into our binder jet printers. This is a form that we almost always use for preliminary testing. So we use it because it goes with the fan. It has a little cantilever. This, we know we have a recipe that works at saturation levels. So the rubber is very, very hard to print with. So it's about 50% rubber and 50% materials. Can we imagine being able to use this material to 3D print objects like outdoor furniture pieces? This rubber proof that you might find on a playground or at a bus stop. Cement, or cement is the most widely used material in architecture and infrastructure construction around the world, but it has to be reconsidered for additive manufacturing. Learned over the years that we can make very complex geometries without formwork or molds. Sometimes these formwork and molds, we use it are up to 40% of the cost of concrete. So there's considerable savings there. And of course, we make these very, very complex ones that would be very challenging to make and would require multi-part molds otherwise. We can print very thinly and thinly enough and post-process with our two-part polymer. We can make translucent concrete as well. And one of the things that I love about this process is that when I model something in the computer, the model that I use to 3D print the physical model to show my client is the same digital model that I use to build the actual piece of architecture. So there are no more intermediary drawings along the way. So there aren't plan sections. There's a one-to-one correlation in the way that we think about design and manufacturing and fabrication. This is a project that we built at the University of California, Berkeley, called Bloom. We did it for the Cyan Cement Group. They asked us to develop their iron oxide-free white cement for additive manufacturing. So we're able to achieve this pattern on the surface through the mapping of a black and white image of cylindrically along the form of the geometry, and the white leaves here become opaque in the actual form itself. And the black parts of the pattern become the finished of the windows and the architecture. And the interior has a very, very different reading. So on the exterior, you see this beautiful pattern, but on the interior, you start to understand the structure of the form itself. So each block cross inside of it, which helps transfer these loads from the top to the bottom and helps brace these very thin walls so they don't collapse. And the flanges on the sides of the blocks allow us to connect one to another, one block to another. So these holes are printed in the blocks, and the blocks are just mechanically fastened together. It's very simple. The blocks at the bottom are about 4 inches deep, so we could print 2 blocks at a time. And the blocks at the top of the structure are about 1 inch deep, so we could print 5 blocks at a time. So you can see here in this plan how thick these blocks are at the bottom and how they get thinner. So even though this is symmetrical, because of that variation in depth, every block is unique. And this helped us optimize the design because one, it reduced the weight from the top to the bottom, but it also allowed us to pick fast. So those are some of the considerations that we had during the design process. And this is how we put the pieces together. You know, everything is alphanumerically coded. It all goes into place perfectly. So you can see even the last block here just plugs right in. Everything comes out of the printer, the exact same dimensions that it's into the printer. And in many instances, when we are making these temporary structures, we take them apart in chunks so we can reassemble them quickly the next time. With sawdust, it's another material of which we have an enormous abundance headed to landfill in the United States, mostly from our industry, from ANC, right? We produce the most wood waste. So how could we take this material and think about developing it? So here just is like a actual cleaner, and you can see how much wood waste this individual is creating, not even in a manufacturing facility, just in. And do you guys have binder jet printers? Okay, so you all know how this works. Binder jet printer, powder goes in, gantry spreads a binding agent across it layer by layer, builds up an object, and then you excavate that object. So it has a built-in support system in the loose material, unlike a desktop printer. So here is our test form again. This is probably one of the first printed wood pieces in the world from many years ago. And sometimes we put other materials in the matrix. So we wanted to see if we put microfibers in there, if that would give this powder formula and ultimately the object more tensile strength. One of the things that I love about 3D printing wood is depending on how you orient the digital model in the build bed of the printer, you can get this kind of artificial wood grain surface of your object. And again, when printed thinly enough, the wood can act like a veneer and be translucent. And we've experimented with different types, species of woods, maple, walnut, and walnut shells, which you can see here in this sawdust screen. So a lot of times we think about, you know, because we're working with a binder jet printer, which has a build bed of 8 by 8 by 10, we can only print 800 words. So how do we think about repeating these parts so that we can rotate them and create a lot of variation across the surface. And of course, clay. So clay isn't a material that we invented, but I would say we're one of the early adopters of 3D printing with full body. And we developed this technique, which we call code clay, which takes essentially a lot of clay for a walk with these wavy surfaces back in around 2015, almost 10 years ago. And you've probably all seen this, but of course, when you have these loops, these glitches, these errors, it makes what is normally a very hard material look soft, even though it's not. So it starts to reference the knitted type stuff. And I love the way that when you're looking at these in the computer, they're actually squares and they have hard 90-degree corners. But when you print them, they sag, and they're curved. And so it's basically just a bunch of errors, it's mistakes, because it's not coming out into the physical world the same way that it was in the digital world. And sometimes even bigger errors occur. So here, for example, we made a really long loop. Maybe it was a really hot, dry day, and the clay was stiff, and so it was broken every time. So this isn't my intended design, but I love that this is the way it turned out. And I think this is so important in architectural education, that you work through these material processes physically, and you don't just imagine what they are and then say, oh, it'll work or it won't work, and never get to that point of actually trying it out. Because you never know what you're going to get. And we developed a software called Fratello, which runs in the cloud. It's very easy to use. It uses these sliders, which allow you to change the profile and the overall form of an object. This is in vessel mode, so it's intended for making vases and cups and smaller objects. But this really lowers the bar to 3D printing. So I can take a sixth grader and show them how to use it 30 minutes. And then in 5 or 10 minutes, they can design something. And then in another 30 or 40 minutes, I can show them how to print with clay on a potter bot. So in one day, we have a group of middle schoolers 3D printing end-use products with clay. And there's an almost infinite possibilities for variation just using these very, very simple sliders. You can see a lot of these forms are the same, but they look different because of the texture of the surface. And recycled plastic. So working with recycled plastic, kitchen waste and food waste in restaurants, and grinding that up to create films for use in a desktop printer. And again, like the clay, kind of taking advantage of the built-in glitches. So in this case, I'm making fur by taking advantage of the bridging command in a standard desktop printer. So I use plastic filament and wood-filled filament to create these light fixtures that have a kind of spax-like quality to them. And they're luminous. So one thing that we've learned over the years is the translucent filament is luminous and see-through, but a lot of times the opaque filament also allows light to pass through as well. So these are some experiments in thinking about using recycled plastic to create interior elements. And also just experimenting like different textures, for example, and how that might be from the light fixture itself. And all of that research comes together in this project that we call the Cabin of 3D Printed Curiosities, which is built in Oakland, California. This was built several years ago at a time when the Bay Area was experiencing a pretty severe housing shortage, which we still have, but since COVID, the prices have come down a little bit. But the cities of Berkeley, Oakland, and San Francisco recognized that there just wasn't enough housing for everyone who wanted or needed to live in the Bay Area. So they relaxed their zoning laws for building ADUs. So you can now build up to 1,200 square feet without a building department, which is great. So it's kind of hard to go to the building department and say, hey, I'm going to build a house out of Chardonnay. So they will respond to that. So we had the opportunity to test these materials in a permanent structure and not a temporary this time. So the front facade of this little cabin is made using the materials that we developed for binder jet 3D printing. So you see here the 3D printed cement, the Chardonnay, the wood. Is sometimes we mix all the materials together and we get some other strange color here because we just recycle it all back in. There's no waste. And these tiles hold the succulents that really thrive in our Northern California environment. And here we can see how over time, the color of these tiles is can expose to the atmosphere and the rain. The roofs and the east and west facades are paste extruded with clay using the Potterware software to create this seed stick texture on the clay tiles themselves. And there's this beautiful play of light and shadow that emerges throughout the day in the garden. And the interior is printed out of bioplastic through fused deposition modeling techniques. And this pattern that we see on the surface here is reminiscent of the Victorian pressed tin tiles that are so common in this neighborhood. The difference being that all of these tiles are unique and not the same, like a pressed tin tile would be. And then almost all of the objects on the interior are printed as well, like the chair, the coffee table, the coffee pot, the light fixture, etc. And of course, as I mentioned, one thing that we learned through this process was that even though we were using an opaque filament, when we put light behind it, the wall glowed, and we decided we didn't need to create a light fixture, that these 3D printed walls could be the light fixtures themselves, and they could be luminous and glow and change colors as you move from day to night, and different things might happen in the interior of the cabin. So for us, this has been really a long program for thinking about how we go from the lab out into the landscape. So I'll talk about moving outwards more, which I would say kind of happened during COVID because the school shut down and our lab was shut down. And we had to take our 3D printers and robot arms and whatever we could grab and put it in the car and bring it home or take it somewhere else. So I'd like to talk about moving outwards into the landscape by talking about geologic architectures and atmospheric architectures. But we'll start with geologic, which includes explorations in stone, salt, and soil. So we've developed salt from the San Francisco Bay Area for additive manufacturing. Salt has been harvested in the San Francisco Bay Area for right now. Yes, what is it, October? Right now, it's of the salt harvesting season. And we harvest about 150,000 tons of salt. You can see, go into these tiles here. This is Ronald and myself at the beginning of the harvest season a few years ago, so you can get a sense of scale, like how much salt we're actually producing there. And the salt goes through these where the water comes from the Pacific Ocean into the San Francisco Bay, and then into these ponds where the water evaporates and the salt crystals are left. And after the year, you're left with about 8 inches of salt, and they scrape off the top 6 inches. and then it starts over the next year. So there's an annual harvest that takes place. So we use the salt to print functional things like the salt shaker. So the exterior of the salt shaker has a binder which makes it solid, but we left the salt loose on the material with the idea that we might be able to sprinkle it out. Again, here's that test piece that we always to see if our formulations, recipes are working. And one of the things that I love about printing the salt is that it's always translucent. The optics of this material are very beautiful. It doesn't matter how thick or thin you print with it. You can always see the light through it. We experimented with different techniques, stacking. And here's just an overview of those crystallizer fields in the South San Francisco Bay. Now, the company that owns all of these crystallizer fields has kept a large portion of it for the continued production of salt. They've also given back a lot to the state for wetland reclamation. And they set aside, I think, 1,000 acres with the idea that they would build housing for about 30,000 people, which made us wonder, is it possible to build this housing out of the salt itself? So could we make a kind of salt igloo or salt igloo for the community that might one day live here? And we were inspired by these very beautiful and traditional forms that we found in the salt making process, the domes and the baskets. And we developed a tile, which the form of which is inspired by a salt crystal itself. And we radially arrayed that salt crystal around this dome-like tent structure to create the salty glue. So here you can see Ariel inside the tent and how the light comes through and how beautiful it is to see these salt pieces lit up. And then there's a stronger light coming through the opening to cast dappled light onto the floor. And here's what it looks like from the exterior. Yeah. Soil. So we do a lot of 3D printing with soil and clay, adobe. We first started going out into the wild to collect our own soil down at the border between the United States and Mexico with students at Tech University. And we were going on these crazy hunts to find clay. And we would just ask people that they did you know, so we can get some clay and some cow. We can get behind the subway. There's a bunch of clay back there. And so you're running around with the river code, digging and processing our own clay for 3D printing and paste extrusion, which was a lot of work, which you can see here. But we got it to a printable formulation. And one of the things that we discovered is that within this very small area around New Mexico and Texas and Mexico, there are a lot of different colors of clay. And we started to think about the complexion of the clay, and not just the coloration of the clay, and how that might connect back to the people who live around. So we worked with the students. And again, these are students who had never 3D printed before. A lot of them were taking their first ceramics class, and they crazy. They made almost 200 pieces, which we then displayed there at the gallery at the university. And simultaneous to that, we had our first which you can see here, which is a really small robot arm, which can print forms that are larger than itself. And we were up on a mesa here overlooking the border between the United States and Mexico, like 3D printing these larger structures. And here you can see that research coming together at the Rubel Center. Following that, we took the printer out into the landscape in southern Colorado, right on the border between the United States and Mexico. So this is the printer. You can use it with a cartridge. You can fill with adobe or clay or any other paste material to it. But we took this cartridge off, and instead we connected a hopper where we were mixing clay and water and straw And we could pump that clay through this black hose and make these larger constructions out of adobe. And we're literally just using the ground that we're digging there, the ground beneath our feet. But here's one of the first structures we made. It's kind of a Pizzelli structure. And the idea here was to 3D print stairs to see if this material could hold the weight of the body. It can. We created a lookout. We made maybe the first 3D printed pit firing kiln in the world. These are some of the pieces that we pit fired in that kiln. And we wanted to know if it would be possible maybe to print a little bit faster and a little bit higher by putting these wooden sticks into the structure to help stabilize the exterior and the interior 3D printed walls, and also wick out some of the moisture so that the prints would dry faster. So we're able to print about, on a windy, sunny day, 18 inches high. Now on a rainy, cloudy day, no. So our lab in the landscape is very dependent on what's happening. This worked quite well, and we were able to print a little bit higher, maybe 20 or 24 inches in height. And we made this hearth where you can come go inside and be protected from the wind and gather around the fire. Only using the local soil, top straw, and water. That's it. A very traditional Adobe recipe. And all of that led to this project that we call the Casa Covida. And this was an opportunity for us to expand that research and to make something larger. So we're still using a Scara printer, which has some limitations. It can only print about 7.5 feet wide. The printer itself is only about 7 feet tall. So it can't print very large structures, but it's very lightweight. So the one strong man can carry the printer on his. I can carry the printer with one other person. So it's very mobile. We can move it around. And in this case, we decided to make this horizontal rail so we could print our 18 inches, slide the printer down, print another one, slide the printer down, print another one. And by the time we finished printing 3 circles, if you will, we could start over on the first one. So we thought we would be able to print faster than we had done in those earlier experiments. So the Casa Covida walls are made of 2 layers, an inner wall and an outer wall. They're both sine waves, and they reflect at every other point. And the geometry of these 3 volumes are spectrums. So the inner wall kind of supports the outer wall as it slopes in. And we can see that these 3 spaces as a space for sleeping, a place for eating, a place for bathing. And here's another invention. Because the printer is only 7 feet, we decided to put it on the box so we could shoot higher. Now we can go up to 12 feet with this very small printer. You can control the printer with your smartphone. So here you can see Ron like driving the printer just with his smartphone. And we used the local beetle kill pine to create lintels for doors and windows, and we just printed right on top of it. And here you can see that space for living and cooking. So you enter here, and there are 2 seats that are made out of local textiles, reprinted dishes out of the micaceous clay, which can withstand being used on the fire itself. And we created a room for sleeping. We built an adobe bed and covered it with sheepskins. And again, worked with a local weaver to create these textiles, the pillows, and the blankets. The most informal pillow here is actually the floor plan of the building. So it's somewhat self-referential. And we imagine this as a place of cohabitation for 2 people to quarantine during COVID, 2 people in love to quarantine during COVID. We worked with Josh Tafoya, who was a Pratt fashion design student who had, of course, come home during COVID and didn't know what to do. So he borrowed his aunt's loom and he started weaving out of the local, using the local wool, dyeing. And he made this beautiful blanket. And here you can see the blanket has patterns, the floor plan of the room, and the reflected ceiling plan of the room for bathing. So this is how I'm using my architectural references. And here's the room for bathing. So you can lay in this tank of water, look up at the sky, and feel both grounded and connected to the air at the same time. So more recently, I've thought about, well, we're doing this, it feels very fixed on the landscape. Things that would be shadows. So I modified my clay 3D printer, my PotterBot, and moved the brains so that I could take it apart and put it in the bus case and take it on the airplane. So now I can go anywhere. So I decided to take it to Italy, to the small town called Faenza, which has a river that runs by it with just enormous amounts of clay. This clay is used all over Italy and the southern part of Europe for production. And you can see how beautiful the town is. All of the brickwork on the cathedral, the relay, everything's made up. And so I went there for an artisan residency, and I was so inspired by these bricks. I thought, well, how can I make a 3D printed brick? What does that look like? And maybe what does a feminine brick look like? And how can I use my software? So I designed this 3D printed brick, which prints in about 5 minutes. And I was exploring the city and, of course, loving the color of the clay, which you can see in the bricks, and the clay around the doors, which is cast to make these beautiful patterns. There are some buildings that are stuccoed over, and you can see the purples and pinks and peaches and the tans of the city. And so I started to dye the local clay so that I could also find those colors and maybe translate them into my bricks to try to then install a historic interior within Faenza. So I started using my printer, but I ended up using Wasp beta testing their continuous flow 3D printing system. So there now, you have a hopper and you can just put your clay in, prints continuously, so you don't have to refill the cartridge. And in terms of thinking about manufacturing, wow, let me tell you, it made a big difference. So I was able to print 1,000 bits and install them in this very beautiful frescoed interior. So we have the colors from the exterior of the city replicated in the interior here. And I call this project Future Documentary 2049 because I understand that it takes about 30 plus years for a new technology to become normalized. So if clay 3D printing was invented in 2010, I think, thereabouts, then we get close to around 2049 when this process and this material will be completely neutralized. It won't be novel anymore. It won't be special. It will be common. We will see it everywhere. And here's just a close-up so you can see the loops. And again, the kind of future of 3D printed clay with maybe the traditions of medieval clay on the floor here. And this summer I had the chance to go back to Italy to do some robotics. And I'm always fascinated by these types of collage, these magnificent quarry spaces, which are architectures in and of themselves. This is in Carrara, and this was through the Digital Stone Project, which was amazing. And if anyone wants to do it, ask me about it because I highly recommend it. So this is a quarry close to the place Pietrasanta where we were visiting. We stayed in this little tiny town called Romazzolo, sorry. But I loved seeing the white marble here, some of it streaked through with gray veins. I got to pick out one piece of stone that I would use to robotically carve my piece, and I love walking inside the mountain. This is inside the mountain. They're creating these marble interiors. And I love seeing stone tools. I'm about this tall. I see the it's there. So, you know, it's Italy. Don't get cut in half here. If you want to say that, everybody go out there. And I've always been taken by the way that artisans and craftspersons are able to take marble and to create something that looks very soft again. You know, thinking about the knitted qualities of the 3D printed clay, or here you see how the master stone carver has created these beautiful folds, fabric, and it even appears translucent. Now, I am no master sculptor. I can't make anything figurative, but I love this. And it made me think that I should make something soft. So, because I'm an architect and interior designer, I like to make furniture. I thought I want to make a chair that would be hard but look soft. And so I proposed these designs. They're big, you know, they're like lounge chairs, maybe a meter by a meter by a meter. And they said, Virginia, they're lovely, but even a master carver could not finish in 1 month. You need to dial it back. So I decided to make something smaller, which is kind of a marble beanbag chair. So I modeled this in the computer, and we spent about $100 carving it out of the white pietra Santa marble here. And I worked really hard to try to finish it so that it would have that soft appearance. So it's carved by the robot, but it's finished. This was about 21 days, 8 hours a day of me working with a small pen grinder to really get into this pattern to create this texture and this very velvety surface. And here's the final piece with different body types and people testing it out. And finally, atmospheric architecture, ash and snow. I had the chance a few years ago to go to Greenland, and I was interested in 3D printing with snow and with ice. And I did a little reconnaissance trip to Greenland, and I realized that this would be very hard because there's a lot of ice and snow already there, but there's not a lot else. There were no 3D printers. There's no filament. There's no nothing. But it's this incredibly beautiful place called Luisiet, which is next to the Lusac ice fjord, which you can see here, which produces 10% of the world's ice floes. So it's the most productive glacier in the world. And it's just a mesmerizing, incredibly beautiful place. They see climate change much faster up there than we here. So the glacier is retreating like hundreds of feet per year. This is the town. The town is made out of wood. All of the wood is imported, mostly from Canada and Scandinavia. So it is the traditional building material. And it has historically been the traditional building material. So even before lumber, plywood, etc., were imported, people were building with wood from shipwrecks, for example, or wood that might wash up the shore. And so I decided, instead of trying to 3D print with ice or snow and bringing in 3D printers, I would work with the materials that were there, which was wood. And I would look at the local craft traditions, which are very gendered. There is a national costume, which has these beautiful beaded collars and boots like this. And they're embroidered in this way, with these little tiny grids. And this is called abutet. And it's a sheer. So the women would take the little scraps the little tiny pieces so that they can use all of the irregular edges of the system and sew them together, dye them and sew them together to make these incredibly beautiful patterns. So I decided I would make a building out of wood and I would use the pattern on the surface of the building. And the idea is that this cut pattern with little ledges which are arranged in the cut pattern would collect the snow when the snow blows and falls. And it would create an analog form of 3D printing. The building would be the build bed of a 3D printer. And I would take advantage of the local craft traditions as a way of thinking about what this indigenous architecture could look like in the future, because their buildings now look like beige buildings. They don't have a greenland accessibility to them. And this building itself is also a barometer for climate change, so we can see how much snow is falling, when it's falling on the surface of the building. And I had done some testing prior to going there. These are actually 3D printed. You can see the snowflake pattern on there. Right? So these are my more, I guess, Northern European or North American sensibility, which they were not interested in Greenland at all. But here's a 3-foot by 3-foot prototype where this wall is standing up straight. And you can see the black and white image of the snowflake, which is more black than white. And in the other one, the prototype is slanted back 45 degrees. And the image is reversed, which is not something that I would have anticipated to be able to model in the computer, right? I could only figure that out by absolutely making it. So I went there and got the local wood, lumber. I worked in a freezing cold space and made the facade of the building and worked for the local contractor to install it on the edge of the disability. And this is what it looks like when it's not snowing. It's kind of this black stealth ship-like structure. And then we can see when the snow starts to fall. And the form is very much inspired by the Zion Church, which is right behind it. And there's a door and a window, so from the street you can go in, be inside and be protected from the wind, snow, and cold. Look out to the icebergs floating by in the distance. And finally, ash. So as you probably know, in California, we have a lot of wildfires. You might remember in 2021, we had so much ash covering the Bay Area that the sun never came up. It literally looked like hell for the entire day. And we've had a lot of wildfires burning. This smoke and ash in Santa Clara County was blowing over my house in Oakland, which is about 45 miles away. So I decided to collect that ash. I collected it off the hoods of people's cars, windowsill, any kind of flat horizontal surface I could store the ash. And it took me a little while to figure out what to do with it. But I decided to collect it and to make a filament for 3D printing with it. So here's my ash, which I then sit down. We compound it by mixing it with biopolymer, which is corn based, and extrude it into a filament that can be used in any desktop 3D printer. So here I'm on my, if you decide to do something like this, you need to increase the nozzle diameter on your printer, but it works pretty well. And one of the things that I like about this material is because it has a lot of impurities in it. It creates a very roughly textured surface on the object. And it doesn't have that same kind of polished or refined finish that your traditional plastic that you would buy from manufacturers or on Amazon would have. So this for me raised questions such as how do we rebuild from the ashes using meaningful biodigital materials? And what artifacts can help us remember what we've lost? And how can materials that are a product of destruction become materials for construction through 3D printing? And I was invited to use this material in a very small installation for Venice I took in LA this year. And so I had the material and the material's working. The question is, what do I make? And I first started thinking, well, what should it look like? What is this form? And then Lottie for the intelligence manifesto. I said, you really need to think about the circularity of this project. No waste. There's nothing in it. So there's already made. I don't know what's to it anymore. It's 3D printed, so I'm not wasting material there. I mean, I'm not just a few little film, but not much. And he said, if you think about the carbon emissions of getting your piece from California to Italy, which let me tell you is very far. Right? So don't make a crate. Don't ship something that's big and gigantic. And when the show is over, I'm not going to throw your piece away. If you want me to throw your piece away, I'm going to find you. So instead of thinking about what I'm going to make, the design parameters became, well, how do I make something that I can get there in my carry-on? So all of these little wafers are very, very thin. They're 2.5 millimeters thick, and they are painted with varying infill lattices, and I removed the solid top and bottom. And then they're very easily connected together. And there was a part of me that was like, oh, this is so simple. I'm going to be embarrassed to start to finish architecture design, because everybody's going to look at it and be like, well, that's so simple. I know how you did that. And then I got there, and there's kind of complexity if you look at this, and everybody's like, how do you make that? What is that? You read that? Is that laser cut? What material is that? And so it made me realize that I could work in the lab with clarity and with purposefulness and with intention, and think about how I could move out into the landscape to create things that are meaningful and beautiful and mysterious at the same time. Thank you. Any questions? Okay.
Thank you for your lecture. It was very interesting. I love 3D printing, so this is a topic that I really enjoyed. But I have two questions. First one, when you 3D printed with coffee and with sugar, did you mix it with a binder that's food safe? Can you actually eat that? Can you actually drink from it?
Yes. So we jet alcohol, like vodka or sake. You can also jet water with just a little bit of rubbing alcohol on it, but that evaporates. But the alcohol just helps push it through the printing. So you could eat it. Now, when we finish it, we post-process it. I use a 2-part epoxy, which is food safe, but of course you can't eat it.
And the other one is when you went to Greenland, you said that you created that structure through analog 3D printing. What do you mean by that?
So I was trying to make the building act like a 3D printer. So when you're binder jet printing, you have a build plate and you deposit the powder on the plate. And then you keep layering it up. Build plate, powder, 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 powder. And so I couldn't take a printer there. So I said, well, what if the building is the build plate? And that's why I built all those little shelves. There's like hundreds of little build plates. And the powder is the snow that's falling from the sky.
That's
So
really
the world is my 3D printer.
Thank you.
Yeah.
Thanks for the talk. It was absolutely beautiful. I was floored. I have two questions which you might have heard before probably, and they're kind of related. One is when you use materials such as the tires, is there ever a problem with toxicity of the materials you're using? How do you deal with that? And then the second one is as this scales up, and you did mention that, you know, it's definitely going to scale up. But there's a lot of composite materials. What happens when they reach the end of their life and we try to recycle or upcycle them? I'm sure that you've thought of processes that can take place there.
Yes, there is an issue of toxicity. I mean, most of the materials like the wood and cotton. But one of the functional and rubber tires, you really have very well custom ventilation system, and we wear respirators. We were working in the lab. But even so, like with the rubber, I still ended up with walking pneumonia. I'm not sure what.
Well, how safe is it if it's in the material? And I know that's even stricter. Okay.
And then like with the California wildfire ash, so the ash that from those two fires, the lightning complex fires in Santa Clara County, was mostly forest. So, and I actually had that ash tested, and I 3D printed some parts and had those tested by a scientist at USC, and he said it's okay. I also went down to LA after the recent trials and got some from the plastic, and he tested that and he said it's not okay. So I'm not going to develop that for 3D printing. But the wildfire ash filament that I have, he said it's fine. You know, just like don't lick it. So yes, I'm thinking about those things. And the recycling of the composite materials is something that we talk about, but it's not something that we influence. You know, I think you could take say, the wood and the polymer, and you could re-separate it again, recycle it, but it's a lot to do that. I would need to partner with someone who had that expertise to really see it through, like the whole.
Yeah, it seems like it's, I mean, it's a bigger problem with a lot of the materials that we have that are a combination of cotton, polyester, and 2% spandex or whatever it is. And I'm wondering if this is one of the things that you're working on, since it's an increasing problem in many.
I think the way that is to think, you know, make these small pieces, and then we, like on the cabin of 3D printed curiosities, they're okay to the facade. So you can take them off and replace them, or you could reuse them somewhere else. And so we think about their reuse and their current.
Thank you so much for your talk. It was really interesting and inspiring. So my question is about the binder jetting part. So you've been exploring different powders and materials for binder jetting. My question is that, like, what were the different binders and how you were selecting them? And the part that you were interested in was that to see if you can print with them, or you were like also comparing like different powders and materials to see like how they work.
Well, the other materials that we mix with them are biomaterials like maltodextrins. They're very organic, they're very safe to use. But that's also one of the reasons that the tiles on the cabin are changing because of the sugar in the part. So some of the binders that we use are the same. Like we might mix maltodextrin with cement, with wood, with sugar, you know, it's just really sticky already. So yeah, they do have different ratios depending on the particle size of the material and the kind of stickiness of the material. Like I mentioned, the rubber is really inert, so I had to use more sugar, whereas with wood I can use less. And then I also have to experiment with different saturation levels. So I need more saturation for concrete. You can jet more liquid on the concrete and less on the wood. So I'm like fine tuning and calibrating each material. Does that answer your question?
Thank you for your presentation. You make everything like look super easy, but I know like as you were talking now, like there's mess going on in the background. I wanted to ask about the challenges you faced being global and local at the same time, like printing, 3D printing in different locations, using different materials. Let's say when you print with concrete, it's like a global material, right? Like sculpt is gonna be the same almost. But what was the challenge of like, you know, you printing with the same machine in different location using soil, other materials, let's say salt or other things?
Yeah, I like to print. Coming down. it doesn't make sense. I want to print for you. I want to print with my morning coffee, and I want to print with the recycled plastic bottles that are coming out of my university. And I want what's global to be maybe the electronic files for getting them shipped around the world. Because that presentations is the so
What's a challenge in that process of you being local and also using a global machine, let's say? Something that you faced doing this, like,
I mean, there was this thing going England. There, right? That really disrupted my plan a lot. And then I had to straighten and rethink it, like the whole thing. The printers are going to become more ubiquitous. You know, the robot arms and the printer will be all over the world by 2041. And we'll be able to print with whatever our local material is. But the printers, I think, are intended to be mobile, whereas the materials are oftentimes very heavy and we need them in very large quantities. It makes sense. And use what's local and what's there and not to ship those print.
Thank you so much for the talk. So I was like, while you were talking about like different materials, like that are also local, and a lot of them are coming from the waste. Like the ones from the rubber and like the ones that from non like cement or wood materials. Do you think that like do you do the research on like the structure capabilities of things, like what is the strength, if they can soon to become accessible and more like mass produced or using in construction as a way of, you know, like reducing the waste and using recycled materials? Do you think like, is that a part of your research or something like?
I myself can't do it. No, there have been times when I've printed little cylinders and dog bombs, and I'll give them to an engineer and they do a test. But that's okay. We did work with a structural engineer from the Costa Covita to make sure it would stand up. It kind of compared the volume of material of Adobe that we use to a regular Adobe. And now Ronald is printing larger structures that meet the building code requirements and working with a structural engineer. Kind of working towards a future where, you know, Icon is 3D printing resin cement buildings, but he and we could print earthen buildings that also meet building code requirements. So I would say the earth is the thing that's moving in that direction of being tested at the scale of full scale architecture, which earth maybe one sort, maybe two, right? But the other materials, I mean, ceramic, you know, then it's 30,000 a year of production. It's not very bad. And then we're also students, like, you know, that project in Greenland. It was me and a local contractor, and he didn't speak English, and I don't speak Greenlandic. And so we did this survey in the language of drawing, but it worked out. So I think the most people we've ever had work on a project was, you know, there's tiny little studio, and we just can't take on everything, like every aspect of this. So I think we live kind of in the early stage R&D and the proof of concept. And a lot of times people ask me, are you going to scale up? And I've kind of decided I'm at scale. This is my scale. I like small buildings, and I like different buildings. And I'm probably not going to make 100 buildings or a skyscraper.
Thank you. Wonderful lecture. I don't have a question, but just you made me think about stuff. And I don't work in this area, so this is all foreign to me. The work that you're doing by taking local materials, by taking waste materials and recycling and generating new objects, new environments works beautifully and amazingly well at the scale that you're working. But I think we are all kind of fighting this global production of goods and junk and, right? You think it allows somebody like you to work at a scale that actually can make a difference environmentally. You're making a difference locally with objects and with small environments, but our problems are at such a different scale. You know, it's like if you could just really imagine what would allow you to really make that, not necessarily scaled, but preparation, really. Thank you.
I mean, I think the consumer has to demand it. Because if the user doesn't demand it, then the companies who have the money to produce aren't gonna make it. Because if it's only ever about time and money, because it is in the United States, you know, it's the race to the bottom very often, then there's no incentive for the companies who are making those huge quantities of furniture and building components to think of waste as a material, as a viable material, and not as waste. And so I think we have to demand it, and we have to ask our clients to demand it. And then these larger companies and contractors will be forced to invest in this kind of, but it's very hard to get investment in the physical world. In Silicon Valley, I can tell you that a very small percent of funding goes to physical products development. It's all going to virtual and digital. I think like 80% of VC funding is AI right now. And so it's just not a priority. And I think the national or the global priorities have to shift. That's my opinion, but I'm not an expert.
Oh, there's a question. Okay. I also had a question. All right. I knew as I was money. I knew as I was asking a question. One of our former students, he's now at Yale doing his PhD. Okay. He wrote, "Thank you for the great lecture!" Exclamation. You mentioned that you're using locally sourced soil for 3D printing. And since soils vary quite a lot and usually need some modification, I was wondering what kinds of processes or material scale tests do you use to characterize the soil that you're using?
Yeah, so we've been printing with soil in regions where building with earth is very prevalent. So in Texas, you know, on the border between the United States and Mexico, around El Paso, it has a history of earthen construction for thousands of years. And on the border of Colorado and northern New Mexico, the longest continuous building in the United States is in California. And it's a 3 or 4 story earthen construction that has been around for over 1,000 years. And so there are these building traditions there already. And we use the same ratios that they use to make adobes in our 3D printing. And we use the jar test, which is kind of the standard. So it's not that scientific. And it's really interesting because the people who've been building with Adobe in this region, it's like they can check their hand in it, they can feel it, and then, yeah, it's right. Or they can taste it, like, yeah, tastes right. And honestly, like, we're okay with that. I mean, there's quantitative methods and there's qualitative, and those qualitative have been around for a long time, probably longer. And so I think it's okay. Yeah.
I also have a question. So first of all, thank you so much for this great lecture. I've known these projects, but it was great to hear the story. And also, yes, I'm amazed by all the works. Big admiration here. But my question is, what brings them together is obviously the 3D printing. Even in the Greenland project, you see it as a form of 3D printing. But you also make a lot of recipes in this, like inventions and most of your, like your presentation was structured about materials. And you explored with your recipes different fabrication techniques like casting or spraying. You always need to 3D print those recipes.
Oh, that's really cool. No, I'm podcast. Probably fine. I'm actually doing some robotically sprayed work with them. So it's in the early phases, really early phases. So I'm not showing it, but yes, yeah.
Yeah, the reason why I ask this is because, you're limited with the binder jet's bed, right? In some of these recipes, but if you cast, that could be a way to, I don't know, scale up, both in terms of size, but also production quantity.
Yeah, I'm gonna use a robot. Same thing. These kind of dancing printers on the way. Everybody else.
Maybe if we have one last question. Oh, yes, Matthew or Andrew. Matthew.
Thank you again. You talked a lot about the emphasis on local materials and local people. I was wondering if the people who are contributing these like waste products, are they aware of what you're doing with them outside of just maybe the company's involvement, or how do you imagine you could involve them in that design process or what you're doing with those products?
Yeah, I mean, when I reach out to people, I always say, hey, this is what I'm doing. And some people care, like they're super interested in it. They want to follow the process, and I send them pictures. And some people don't care. So, like, I also did a lot of 3D printing with eggshells, and I went to, my local cafe, and he's like, how many do you need? 1,000. He's like, okay. We crack 1,000 eggs a day. Like, come back tomorrow. And but I just didn't. So as much as they want to be involved, I will involve them because I like that dialogue, And plus, these people are like experts with their own materials, and I'm not. And so if they want to be more involved and we can have a conversation, then I feel like I'm going to learn more and I'm going to make whatever the outcome is better.
Thank you.
Right. Thank you so much, Virginia, for this amazing.